Have you ever looked up at the night sky and wondered, why? Why are we all here? What's out there? And how does it all work? Well, you're certainly not alone. Hello everyone, and welcome to The Big Why. I'm just as curious as you are about the universe and everything in it. From the depths of the ocean to the furthest reaches of space, no question is too big, no topic too strange for us. We'll crack open the mysteries of black holes, journey to the edge of the universe, and explore the mind-blowing discoveries that are changing our world. So if you're ready to unleash your inner scientist, ask the tough questions, and explore the universe alongside me, then buckle up. And let's ask why. Today we'll be venturing into the great unknown. We'll be exploring the vast expanse that lies beyond our planet, the brilliant minds who have dedicated their lives to unraveling its secrets, and the countless mysteries that continue to baffle us. For centuries, space has challenged our understanding of the universe, but who knows? The answer to the spacious question might be closer than we think. Perhaps one day, someone watching this video will be the one to change our understanding of space forever. So what exactly is space? Simply put, it's the vast expanse that lies beyond the reach of any celestial body and its atmosphere. Think of it like the ultimate cosmic ocean, stretching out in every direction, with planets, stars, and galaxies like islands dotting its endless surface. But this ocean isn't filled with water. Instead, it's a near-perfect vacuum, meaning it's almost completely empty. There are just a few stray particles drifting around, mostly hydrogen and helium plasma, the same stuff stars are made of. But that's not all. Space is also buzzing with energy. There's electromagnetic radiation like light and radio waves, cosmic rays zipping through, ghostly neutrinos, and even invisible magnetic fields. Now, you might think space is a chilly place. And you'd be right. The average temperature out there is an unbelievably cold -455 degrees Fahrenheit. That's the leftover chill from the Big Bang, the event that kick-started our universe. The vast majority of space isn't even inside galaxies or solar systems. It's the space between them. A seemingly empty expanse that actually holds a surprising amount of stuff. Scientists believe this intergalactic space contains most of the regular matter in the universe, just spread out incredibly thin. So even though it seems empty, space is actually teeming with invisible matter and energy that we're still trying to understand. Now you might be wondering, where exactly does space begin? It's not like there's a giant signpost out there. In fact, there's no clear boundary between Earth's atmosphere and outer space. But to keep things simple, we use an imaginary line called the Kármán line about 62 miles above sea level as the official starting point of outer space. But just because there's no hard line doesn't mean there aren't some interesting zones in between. The upper parts of our atmosphere, like the stratosphere and mesosphere, are sometimes called near space. It's a region where the air gets thinner and thinner, and the effects of space start to become more noticeable. Speaking of noticeable, did you know that space isn't actually lawless? There are international treaties in place, like the Outer Space Treaty, that help to govern what countries can and can't do out there. It's kind of like the Wild West of the cosmos, but with some rules to keep things from getting too chaotic. Despite these rules, humans have been venturing into space for decades, pushing the boundaries of exploration. It all started with high-altitude balloons, followed by the first crewed rocket flights, and eventually the historic moment when Yuri Gagarin became the first human to orbit the Earth. Of course, space travel isn't cheap or easy. It takes a lot of resources to send anything, let alone a person, into orbit. That's why most human spaceflight has been limited to low Earth orbit and the moon. But that doesn't mean we haven't been busy. Uncrewed spacecraft have journeyed to every planet in our solar system, sending back incredible images and data. And while space may seem like a hostile environment, with its vacuum, radiation, and microgravity, it hasn't stopped us from dreaming of exploring it further. Who knows, maybe one day, you'll be the one to take that next giant leap for humankind. Interestingly enough, the word space as a way to describe the area beyond Earth's sky has a longer history than you might think. It dates back to the 17th century, even making an appearance in John Milton's epic poem Paradise Lost. The term outer space came a bit later, first popping up in a poem in 1842, but it really gained traction through the works of science fiction writers like H.G. Wells in the early 20th century. Now, when we talk about things in space, we use some cool terms. Spaceborne means something that exists in outer space, usually carried by a spacecraft. So astronauts on the International Space Station are spaceborne, as are satellites orbiting the Earth. And if something is space-based, it means it's either located in space or another planet or moon. For example, A space-based telescope is one that orbits the Earth, giving us a clear view of the universe. It's fascinating to see how our language has evolved to describe the wonders of space. And as we continue to explore and learn more, who knows what new words and ideas will emerge to capture the mysteries of the cosmos. The universe as we understand it began with the Big Bang, a colossal explosion of energy that occurred about 13.8 billion years ago. Back then, everything was packed into an incredibly hot, dense state. But in a fraction of a second, it expanded rapidly, and it's been expanding ever since. It took about 380,000 years for things to cool down enough for atoms to form, and that's when light was finally able to travel freely through space. Now, because light travels at a finite speed, we can only see a certain portion of the universe, the part from which light has had time to reach us. It's like a bubble of visibility centered around Earth, and we call it the observable universe. But the whole universe? Well, we don't actually know how big it is. It could be finite, or it could stretch on forever. It's a mystery that continues to challenge our understanding of the cosmos. What we do know is that the universe isn't just expanding, it's actually accelerating. This accelerated expansion is driven by a mysterious force called dark matter, which makes up about 70% of the universe's total energy density. And that's not all. There's also dark matter, an invisible substance that accounts for about 25% of the universe. So even though we can only see about 5% of the universe, the regular matter made up of atoms, it's just a tiny fraction of what's actually out there. Speaking of matter, the density of the universe varies greatly from place to place. It's densest in galaxies where stars, planets, and even supermassive black holes reside. But in the vast voids between galaxies, the density drops dramatically. It's a cosmic tapestry of contrast, with regions of intense activity and seemingly empty stretches all contributing to the grand symphony of the universe. Now let's dive deeper into the unique properties of outer space. As we mentioned earlier, it's the closest thing to a perfect vacuum we know of. This means there's practically no friction out there. Imagine a place where stars, planets, and moons can glide effortlessly along their orbits, almost like they're on cosmic ice skates. This vacuum isn't completely empty though. There are still a few hydrogen atoms floating around per cubic meter. Compare that to the air we breathe, which is packed with the 10 to the 25th integer molecules in the same space. That's 10 followed by 25 zeros. This low density allows electromagnetic radiation, like light and radio waves, to travel vast distances without being scattered. That's why we can see stars and galaxies that are billions of light years away. But even in this near vacuum, there are things that can block light. Dust and gas clouds, especially in galaxies, can absorb and scatter photons, making them difficult to see. It's a bit like trying to look through a dusty window. You can still see shapes, but the details are obscured. You might be wondering how planets and moons manage to hold on to their atmospheres in this vacuum. It's all thanks to gravity. The stronger the gravity, the better an object can hold on to its atmosphere. But there's no clear-cut boundary where the atmosphere ends and space begins. It gradually fades away, like a painting that blends into the background. Space also has a unique smell. According to astronauts who have ventured outside their spacecraft, they describe it as a burned or metallic odor, similar to the scent of a welding torch. It's a strange and unexpected sensation, a reminder that space is full of surprises. Space may seem inhospitable, but life is surprisingly resilient. Believe it or not, certain organisms have shown they can survive the harsh conditions of space for extended periods. Lichen, those crusty growths you see in rocks and trees, have survived exposure to space for days. Even some plant seeds, like those from tobacco, have germinated after spending over a year in space. There's even a type of bacteria that has survived for almost 2 years in both low Earth orbit and simulated Martian environments. These discoveries have led to a fascinating theory called lithopanspermia. It suggests that life could hitch a ride on rocks ejected from one planet and travel through space to another, potentially seeding life on a new world. Some scientists even believe this could have happened early in our solar system's history, with microorganisms potentially being exchanged between Earth, Mars, and Venus. This idea challenges our understanding of how life spreads and evolves. Who knows what other secrets about life in the universe are waiting to be discovered in the vast expanse of space? Now let's talk about one of the most immediate dangers of space: the vacuum. You see, space has virtually no pressure, which is a big problem for us humans. As you go higher above Earth's surface, the pressure drops. At a certain altitude, around 11.89 miles up, the pressure gets so low that it matches the vapor pressure of water inside our bodies. This is called the Armstrong line, and it's not a place you want to be without protection. Above this line, the fluids in our bodies, like saliva, tears, and the moisture in our lungs, would start to boil away. Imagine that. That's why astronauts need pressurized suits or capsules to survive at those altitudes. If you were exposed to the vacuum of space without protection, it would be, well, not pretty. The sudden drop in pressure could cause your lungs to rupture, your eardrums and sinuses to burst, and your blood to literally boil. This terrifying condition is called ebullism, and it's definitely not something you want to experience. But don't worry. Astronauts have special suits to protect them from all of this. These suits create a pressurized environment that keeps their body safe and sound even in the most extreme conditions. So, while the vacuum of space might seem like an insurmountable obstacle, human ingenuity has found ways to overcome it. We've designed suits and spacecraft that allow us to explore this harsh environment and push the boundaries of our knowledge. Living in the weightlessness of space also presents unique challenges for our bodies. We humans evolved under the constant pull of Earth's gravity, so floating around without that familiar force can have some strange effects. Many astronauts experience space motion sickness, which can cause nausea, dizziness, and even headaches. It's like a never-ending roller coaster ride, but thankfully, it usually subsides after a few days as the body adapts. But the effects of weightlessness go beyond just feeling queasy. Extended stays in space can lead to muscle atrophy where muscles become weaker and smaller. Bones can also weaken, a condition called spaceflight osteopenia, which is similar to osteoporosis. It's like our bodies forget to use those muscles and bones without the constant tug of gravity. But don't worry, astronauts have exercise routines to help counteract these effects and stay healthy in space. Radiation is another significant concern for space travelers. Out in the vastness of space, we're exposed to high-energy cosmic rays that can damage our cells and DNA. Short-term effects can include fatigue, nausea, and changes in blood cell counts. But over the long term, radiation exposure increases the risk of cancer and can damage the eyes, nervous system, and other organs. Think about a mission to Mars, which would take about 3 years round trip. During that time, a significant portion of an astronaut's cells would be exposed to and potentially damaged by these harmful rays. Thankfully, spacecraft provide some shielding, and scientists are constantly researching ways to protect astronauts from radiation during those long-duration space travels. It's clear that space travel is not without its risks, but the potential rewards of exploring the cosmos are immense. By understanding the challenges and developing solutions, we can continue to push the boundaries of human exploration and unlock the secrets of the universe. Now let's address the big question. Where does space actually begin? As we've already touched on, there's no clear-cut line where the Earth's atmosphere simply stops and space begins. Instead, it's a gradual transition, like a fade-out in a movie scene. The air gets thinner and thinner as you go higher, eventually blending into the solar wind, a stream of charged particles emanating from the sun. So, how do we define the boundary of space? Well, there are different ideas depending on who you ask. Some say it starts as low as 19 miles above sea level, while others argue it could be as far out as 990,000 miles. It's a bit of a gray area, but we have a few reference points to help us out. High-altitude balloons have soared as high as 31 miles, while certain aircraft, like the X-15 rocket plane, have reached altitudes above 50 miles. But to be considered an astronaut, you need to go a bit higher. Until recently, the US defined astronauts as anyone who traveled above 50 miles, but now it's reserved for spacecraft crew members who contribute to human spaceflight safety. So, it's not just about reaching a certain altitude, it's about what you do while you're up there. In 2009, scientists found an interesting midpoint around 73 miles up, where the gentle winds of Earth's atmosphere give way to the more chaotic flows of outer space. It's like a cosmic changing of the guard, where one realm ends and another begins. Then there's the Kármán line, set at 62 miles above sea level. This is the internationally recognized boundary between Earth's atmosphere and outer space. It's named after Theodore von Kármán, who figured out that at this altitude, a vehicle would need to travel faster than orbital velocity to stay aloft, essentially becoming a spacecraft instead of an aircraft. So, while the exact boundary of space remains a bit fuzzy, we have these reference points to guide us. Whether it's the Kármán line, the 50-mile mark, or somewhere in between, one thing is certain. The journey from Earth's atmosphere to the vastness of outer space is a remarkable transition, full of wonder and possibility. Now, You might think that space, being so vast and seemingly untouched, is a lawless frontier, but you'd be surprised. There's actually a whole system of international space law in place to help manage our activities beyond Earth. The foundation of this legal framework is the Outer Space Treaty, which was signed by over 100 countries back in 1967. This treaty declares that outer space, including the moon and other celestial bodies, belongs to all of humankind. It's like a cosmic public park, where everyone has the right to explore and use space peacefully. Of course, this also means that no single country can claim ownership of the moon or any other celestial body. The Outer Space Treaty also prohibits the placement of nuclear weapons in space, aiming to keep the cosmos a peaceful domain. However, it doesn't explicitly ban conventional weapons, and some countries have even tested anti-satellite weapons, adding a new layer of complexity to the space law landscape. The United Nations has also played a significant role in shaping international space law. They've passed numerous resolutions promoting cooperation in space exploration and trying to prevent an arms race in the cosmos. It's an ongoing effort to ensure that space remains a place for peaceful collaboration and scientific discovery. However, one issue that's becoming increasingly important is the growing problem of space debris. As we launch more and more satellites and spacecraft, the amount of junk orbiting our planet is increasing. This debris poses a risk to operational satellites and future space missions. So, while we've made great strides in establishing a legal framework for space, new challenges continue to emerge, requiring us to adapt and find solutions to ensure the long-term sustainability of our activities in space. Now let's talk about Earth's orbit. It's a pretty amazing feat of cosmic balance, and it's essential for our understanding of space travel. Imagine a spacecraft trying to enter orbit around our planet. To do that, it needs to find the sweet spot where the pull of Earth's gravity is perfectly balanced by the outward force created by its horizontal velocity. For a low Earth orbit, this means whizzing around the planet at a speed of about 17,400 miles per hour. That's incredibly fast. To put it into perspective, the fastest piloted airplane ever built only reaches about 4,900 miles per hour. So, how does a spacecraft achieve this incredible speed and reach orbit? Well, it needs a powerful rocket to boost it up to the right altitude and velocity, and the energy required to reach orbit is about 6 times the energy needed just to climb to that altitude. It's like sprinting up a hill and then leaping off the top at full speed. But once a spacecraft is in orbit, it doesn't stay there forever. Low Earth orbit, where many satellites and the International Space Station reside, is still within the grasp of Earth's atmosphere. The drag from the thin air gradually slows down the spacecraft, causing it to lose altitude and eventually re-enter the atmosphere. The lower the orbit, the faster this decay happens. Some satellites in very low orbits only last a few days or weeks before burning up in the atmosphere. But at higher altitudes, spacecraft can stay in orbit for centuries. It's a delicate balance between the forces of gravity and drag, and it's a crucial factor in planning any space mission. Now let's zoom in a bit and explore the regions of space closer to home. The area around Earth known as near-Earth space is a bustling hub of activity. It extends from low Earth orbit, where many satellites zip around the planet, out to geostationary orbit, where satellites match Earth's rotation and appear to hover in the sky. This region is crucial for our daily lives. It's where we find communication satellites that enable our phone calls and internet access, weather satellites that help us predict storms, and navigation satellites that guide our GPS devices. It's a busy place filled with human-made objects that have become essential to our modern world. However, again, this increased activity has also led to a growing problem: space debris. Imagine a junkyard in space filled with old satellites, spent rocket stages, and fragments from collisions. This debris poses a threat to other spacecraft and satellites, increasing the risk of collisions and damage. It's a very serious issue that scientists and engineers are working hard to address, but it's a reminder that even in the seemingly pristine environment of space, our actions can have unintended consequences. Despite the challenges, near-Earth space remains a fascinating and dynamic region. It's a place where human ingenuity and exploration are constantly pushing the boundaries of what's possible. Who knows what new discoveries and technologies await us in this ever-evolving frontier? Zooming out a bit further, we encounter a region known as Geospace. This is essentially Earth's personal bubble in space, encompassing our planet's upper atmosphere and the protective magnetic field that surrounds us, called the magnetosphere. Within this bubble, we find the famous Von Allen radiation belts, 2 donut-shaped rings of charged particles trapped by Earth's magnetic field. The outer edge of geospace is defined by the magnetopause, where our planet's magnetic field pushes back against the constant stream of particles from the sun known as the solar wind. Now here's the fascinating part. Geospace isn't static. It's constantly changing and evolving in response to the sun's activity. Solar flares and eruptions can trigger geomagnetic storms that wreak havoc on our planet's magnetic field. These storms can disrupt satellite communication, interfere with GPS signals, and even pose a threat to astronauts in space. They also create the mesmerizing auroras, those shimmering curtains of light that dance across the skies near the Earth's poles. Think of geospace like a cosmic weather system, with the sun acting as the ultimate influencer. The constant interplay between the solar wind and Earth's magnetic field creates a dynamic and sometimes turbulent environment. Scientists who study this field, known as heliophysics, are constantly working to better understand these complex interactions and their impact on our planet and technology. So while geospace might seem like just another layer of space, it's actually a vital part of our planet's environment. It shields us from harmful radiation, influences our weather patterns, and plays a crucial role in the complex dance between Earth and the Sun. Venturing even further from Earth, we enter the vast realm of Geospace. This is a term coined by the US to describe the region between geosynchronous orbit, extending all the way out to the gravitational sweet spot between Earth and the Moon, known as the L2 Earth-Moon Lagrange point. Geospace encompasses a variety of interesting regions, including cislunar space, which is the area around the Moon. This region is gaining increasing attention as a potential hub for future space exploration and resource utilization. It's a place where we could potentially build lunar bases, mine resources, and even launch missions to deeper parts of the solar system. Beyond cislunar space, we enter translunar space, the region where spacecraft travel on their way to and from the Moon. It's like a cosmic highway connecting our planet to its natural satellite. Of course, Earth's gravitational pull doesn't simply stop at the Moon. It extends much further, forming a region called the Hillsphere, where Earth's gravity is dominant over that of other celestial bodies. Think of it like Earth's personal gravitational bubble. But as we journey even further, we eventually reach a point where Earth's gravity loses its grip, and the sun's influence takes over. This is where deep space truly begins. It's the vast expanse beyond our planet's immediate neighborhood, encompassing the outer reaches of our solar system and the vast distances between stars. The definition of deep space can vary, but it's generally considered to be the region beyond the Moon's orbit or even beyond the furthest reaches of our solar system. It's a place where the sun is just another star in the sky, and the vastness of the cosmos truly hits home. It's a place of endless possibilities and unimaginable mysteries just waiting to be explored. As we journey away from Earth, we enter the vast realm of interplanetary space. This is the space within our solar system, the region between the planets and the sun, extending all the way out to where the solar wind, a constant stream of charged particles from the sun, finally loses its strength. The solar wind creates a tenuous atmosphere called the heliosphere, which envelops our entire solar system like a giant bubble. Inside this bubble, the solar wind carries about 5 to 10 protons per cubic centimeter, traveling at speeds of hundreds of thousands of miles per hour. That's like a cosmic breeze constantly blowing through our solar system. The heliosphere acts as a shield, protecting us from most of the low-energy cosmic rays that come from outside of our solar system. It's like a cosmic force field keeping us safe from harmful radiation. But don't be fooled by the term space. Interplanetary space isn't entirely empty. It's sparsely populated with cosmic rays, which are higher energy particles zipping through the void. There's also some gas, plasma, dust, and even tiny meteoroids. Scientists have even discovered various organic molecules floating around out there, the building blocks of life. One fascinating feature of interplanetary space is the zodiacal light, a faint band of light that you can sometimes see in the night sky. It's caused by sunlight reflecting off dust particles scattered throughout the solar system. And let's not forget the magnetic fields. The sun has a powerful magnetic field that extends throughout interplanetary space. Planets like Earth, Jupiter, Saturn, and Mercury also have their own magnetic fields, which interact with the solar wind in complex ways. These magnetic fields can trap charged particles, creating belts of radiation around some planets, like the Van Allen belts around Earth. But planets without strong magnetic fields, like Mars, are more vulnerable to the solar wind, which can gradually strip away their atmospheres. Interplanetary space is a dynamic and ever-changing environment shaped by the sun's activity and the interactions between different celestial bodies. It's a place of incredible beauty and scientific intrigue, and it holds the key to understanding our place in the solar system and beyond. Leaving our solar system behind, we venture into the vast expanse of interstellar space. This is the region between star systems within a galaxy, a seemingly empty void that's actually filled with a thin soup of matter and radiation known as the interstellar medium. It's like the cosmic space between the stars. The interstellar medium is mostly made up of hydrogen atoms with a sprinkling of helium and trace amounts of heavier elements forged in the fiery hearts of stars. These elements are released into space through stellar winds, planetary nebulae, and the explosive deaths of massive stars known as supernova. Now, you might think interstellar space is just a vast empty expanse, but it's actually quite dynamic. The density of matter varies greatly, from relatively empty regions to dense clouds of gas and dust where new stars are born. Within these clouds, complex chemical reactions take place, leading to the formation of a wide array of molecules, including organic compounds, the building blocks of life. In our own galactic neighborhood, we have the local interstellar cloud, a region of space within 30 light years of the sun. It's relatively sparse compared to other regions, but it still contains an abundance of interstellar gas and dust. It's like our local cosmic backyard, a place where we can study the interstellar medium up close and learn more about the conditions that exist between stars. As stars move through the interstellar medium, they create their own bubbles of influence called astrospheres. These bubbles are formed by the stellar wind, a stream of charged particles emanating from the star. The boundary between the astrosphere and the interstellar medium is called the astropause. For our sun, we call this bubble the heliosphere, and its boundary is the heliopause. Sometimes when stars move fast enough, their astrospheres create bow shocks as they plow through the interstellar medium. Think of it like a boat creating a wave as it moves through water. For a long time, scientists believed that our sun also had a bow shock, but recent data suggests that's not the case. Instead, we have a subsonic bow wave, a gentler ripple that marks the transition from the solar wind to the interstellar medium. So as you can see, interstellar space is far from empty. It's a complex and ever-changing environment filled with raw materials for new stars and planets, and perhaps even the seeds of life itself. Now, if we zoom out even further, we leave behind individual galaxies and enter the vast realm of intergalactic space. This is the space between galaxies, and it's even emptier than interstellar space. Imagine the universe as a giant cosmic web with galaxies clustered together like sparkling beads on delicate threads. The space between these threads, that's intergalactic space. The structure of the universe is like a cosmic foam, with clusters and filaments of galaxies forming the bubbles, and vast voids making up the empty spaces between them. These voids are truly enormous, spanning millions of light years, and while they might seem empty, they're actually filled with a very thin, extremely hot gas called the intergalactic medium. It's so thin that it has only about 1 atom per cubic meter, but it's incredibly hot, with temperatures ranging from tens of thousands to millions of degrees. This hot gas is thought to make up a significant portion of the ordinary matter in the universe. As gas from these voids falls towards the clusters of galaxies, it gets even hotter, forming a superheated plasma called the intracluster medium. Think of it like a cosmic whirlpool where gas is drawn in and heated to extreme temperatures. So even though intergalactic space might seem like the most desolate place imaginable, it's actually teeming with activity on a grand scale. The movement of gas, the formation of galaxy clusters, and the vast voids all contribute to the ever-evolving structure of the universe. It's a place of incredible extremes where the vastness of space and the power of gravity create a truly awe-inspiring spectacle. Our understanding of space has evolved over centuries, with brilliant minds grappling with its mysteries and challenging prevailing beliefs. Back in ancient Greece, the philosopher Aristotle believed that nature abhorred a vacuum, a concept known as oa vacui. He thought that space couldn't be empty, a notion that persisted for centuries. In ancient China, however, the astronomer Zheng He had a different view. He believed that space was infinite, expanding far beyond the sun and stars. He envisioned a boundless expanse, empty and void of substance, where celestial objects move freely. Fast forward to the 17th century, where the Italian scientist Galileo Galilei made a groundbreaking discovery. He realized that air has mass and is subject to gravity, paving the way for a new understanding of the nature of space. His student, Evangelista Torricelli, took this further and created the first partial vacuum in 1643 using a mercury barometer. This experiment caused a sensation in Europe and opened the door for further exploration of the vacuum. Blaise Pascal, a French mathematician, then had a brilliant idea. He reasoned that if air pressure supported the column of mercury in a barometer, then the column should be shorter at higher altitudes where the air is thinner. His brother-in-law tested this theory on a mountaintop in France and confirmed Pascal's hypothesis. This experiment, along with others like it, gradually chipped away at the idea of oa vacui and paved the way for our modern understanding of space as a vacuum. As our understanding of space evolved, so did our ideas about the nature of the universe itself. In the 15th century, German theologian Nicholas Cousins proposed that the universe had no center or circumference. He imagined a universe that, while not infinite, was unbounded, challenging the prevailing geocentric model. Italian philosopher Giordano Bruno took this idea even further in the 16th century, proposing an infinite universe filled with a substance called aether. This aether was thought to be the medium through which light traveled, a concept that gained traction among scientists for centuries. However, in 1887, the Michelson-Morley experiment failed to detect any evidence of aether, throwing the scientific community into a frenzy. It wasn't until Albert Einstein introduced his theory of spatial relativity that we had a new framework for understanding the universe. Einstein showed that the speed of light is constant in a vacuum, regardless of the observer's motion, and that there was no need for aether to explain its behavior. The true scale of the universe started to reveal itself in the 19th century, when astronomers began measuring the distances to nearby stars. In 1838, Friedrich Bessel successfully measured the distance to 61 Cygni, a star system over 10 light-years away. This groundbreaking achievement opened our eyes to the vastness of the cosmos. Later in 1923, Edwin Hubble made another monumental discovery. By measuring the brightness of Cepheid, variable stars in the Andromeda galaxy, he determined that it was far beyond the Milky Way, proving that our galaxy was just one of many in the universe. This realization revolutionized our understanding of the cosmos and paved the way for modern cosmology. The modern concept of outer space is based on the Big Bang theory, which was first proposed by Georges Lemaitre in 1931. This theory posits that the universe began in a hot, dense state and has been expanding and cooling ever since. Even the temperature of outer space has been a subject of scientific inquiry. In 1896, Charles E. Guillaume made the first estimate, suggesting that space was heated to 5 to 6 Kelvin due to the background radiation of stars. Over the years, other scientists refined this estimate, and today we know that the average temperature of space is about 2.7 Kelvin, thanks to the cosmic microwave background radiation, the afterglow of the Big Bang. As you can see, our understanding of space has been a long and winding journey, filled with groundbreaking discoveries, revolutionary theories, and relentless pursuit of knowledge. And it's far from over. The universe still holds countless mysteries, and each new discovery brings us closer to understanding our place in the cosmos. Humanity's fascination with space has led us on remarkable journeys of exploration. For most of history, we could only gaze at the stars from Earth, using our eyes and then telescopes to unlock their secrets. But our thirst for knowledge went far beyond mere observation. We dreamed of reaching the stars, and eventually we found a way. High-altitude balloons were our first foray into the upper reaches of Earth's atmosphere. Then came rockets, powerful enough to propel us even higher. In 1957, the launch of Sputnik 1, the first artificial satellite, marked a turning point in human history. We had finally put an object into orbit around our planet. The space race was on. And just a few years later, in 1961, Yuri Gagarin became the first human to journey into space, orbiting the Earth aboard Vostok 1. It was a monumentous achievement that captured the world's imagination and sparked a new era of space exploration. But we didn't stop there. In 1968, the Apollo 8 mission took 3 astronauts further than any human had ever been before. They orbited the moon, witnessing the Earth rise above the lunar horizon for the first time. It was a sight that changed our perspective on our place in the universe. And while humans have ventured as far as the moon, our robotic emissaries have gone much further. Uncrewed spacecraft have visited every planet in our solar system, from scorching Mercury to the icy Neptune and even beyond. They've captured stunning images, gathered valuable data, and expanded our understanding of the cosmos in ways we never thought possible. In 2012, the Voyager 1 spacecraft made history by becoming the first human-made object to leave our solar system and enter interstellar space. It's a testament to human ingenuity and our unyielding curiosity about the universe. And who knows what other incredible milestones await us as we continue our journey of exploration. Beyond its scientific significance, outer space has become a valuable asset to our global society with numerous practical applications that benefit our economy and daily lives. One of the most impactful uses of space is the deployment of artificial satellites. These technological marvels orbit our planet and provide us with a wide range of services. They enable long-distance communication, allowing us to connect with people across the globe through phone calls, video chats, and the internet. They provide precise navigation, guiding our ships, planes, and even our smartphones. They monitor weather patterns, helping us predict and prepare for storms, and offer remote sensing capabilities, giving us valuable insights into our planet's health and resources. Satellites can track soil moisture for agriculture, predict water runoff from melting snow, detect diseases in crops, and even monitor military activities. They play a crucial role in tracking climate change and its impact on our environment. The unique conditions of space, with its lack of atmospheric drag, allow satellites to maintain stable orbits and efficiently cover the entire globe, making them indispensable tools for a variety of purposes. Space also provides an ideal environment for astronomy. Without the interference of Earth's atmosphere, telescopes in space can observe the universe across the entire electromagnetic spectrum, from radio waves to gamma rays. The Hubble Space Telescope, for example, has captured breathtaking images of distant galaxies and nebulae, allowing us to peer back in time to the very beginnings of the universe. Different locations in space offer unique advantages for different types of telescopes. For instance, placing infrared telescopes beyond the dust clouds of our solar system allows for clearer observations of faint objects like exoplanets. Likewise, the far side of the moon, shielded from Earth's radio interference, could be an ideal location for a radio telescope. As you can see, space is not just a vast and mysterious realm, it's also a valuable resource that we've harnessed for the betterment of our lives. From communication to scientific discovery, the applications of space are far-reaching and continue to expand as our technology and understanding evolve. Believe it or not, the unique environment of space isn't just for astronauts and satellites. It also has some pretty exciting potential for industrial applications. One area where space could really shine is manufacturing. The ultra-clean vacuum of space is perfect for processes that require pristine surfaces, like creating high-quality semiconductors or developing new materials. Of course, setting up shop in space isn't cheap or easy. It requires significant financial investment and overcoming logistical hurdles like transporting materials and equipment. But the potential benefits are enormous, with the possibility of developing revolutionary technologies and products. Interstellar travel, a staple of science fiction, remains a distant dream for now. The vast distances between stars present a formidable challenge, requiring breakthroughs in propulsion technology and life support systems to sustain crews on journeys lasting decades or even centuries. But that doesn't mean we've given up on the idea. Scientists and engineers are exploring various concepts for interstellar travel, like fusion-powered spacecraft, light sails, and even using antimatter as fuel. While these ideas are still theoretical, they ignite our imaginations and push the boundaries of what we believe is possible. And even if we can't travel to other stars just yet, space still has something to offer us here on Earth. The ultra-cold temperature of outer space can be used as a renewable energy source for cooling. By harnessing the natural processes of radiative cooling, where heat radiates away into space, we can develop innovative cooling technologies for buildings and other applications. It's a fascinating example of how the extreme conditions of space can be harnessed to benefit our lives on Earth. As we continue to explore and understand the vastness of space, who knows what other incredible applications and possibilities we'll uncover. The future of space is limited only by our imagination and our determination to reach for the stars. From the mind-boggling vastness of intergalactic space to the bustling activity in near-Earth orbit, the universe is an endless source of wonder and discovery. It's a place that challenges our understanding, ignites our imaginations, and beckons us to explore its infinite possibilities. Who knows what secrets still lie hidden in the depths of the cosmos? Perhaps you, the curious minds watching this video, hold the key to unlocking them. Maybe you'll be the one to develop the technology that takes us to the stars, or the one to uncover the secrets of dark matter and dark energy. Maybe you'll be the one to discover life on another planet, or even find a way to make space travel accessible to all. The future of space exploration is in your hands. Your curiosity, your passion, and your ingenuity could be the driving force behind the next giant leap for humankind. So keep looking up, keep asking questions, and never stop dreaming. The universe is ours to explore. Thank you everyone for watching. My name's The Big Why. Don't forget to drop a like, and if you're new to the Why Not family, a follow. And I'll catch you guys in the next video.